Margaret Mitchell is Chief Ethics Scientist and Researcher at Hugging Face. Mitchell founded the Ethical AI Group and co-founded the ML Fairness Initiative at Google Research, having previously contributed to AI advancements at Microsoft Research. Mitchell works to bridge machine learning, natural language processing, and computer vision in order to design AI systems aligned with human contexts and needs. Please join me in welcoming Margaret Mitchell.
Thanks. It's a really intimidating act to follow. That was so impressive. Great. Okay, cool. So, yeah. Hopefully everyone can hear me okay. Great, cool. So what I wanted to do today was build from my experience working in the tech industry to talk about some of the lessons I've learned and some sort of concrete research solutions that I think could be further expanded in order to try and provide people with information about where we should be going next, and hopefully some insights on how to build more ethical AI that can ultimately benefit people. Let's see. Okay, cool. So 2013 was a really exciting time to be in AI research. Deep learning had recently been shown to be competitive with other statistical methods for things like image classification. And many of us were working on ways that the gains that we found in computer vision with deep learning could be translated to natural language processing. I had done my thesis connecting vision to language, so taking computer vision output and using it to generate natural language. And was privileged to be part of the frontier of researchers at Microsoft, creating some of the first large-scale, automated, realistic descriptions of images for the first time. I'd come to work on this from a background that included assistive and augmentative technology, with particular attention to natural language generation. So it's been particularly interesting to me to see how natural language generation has evolved over the past 10, 20 years, where it's really diverged from some of the initial ideas that we had in working on it. But I imagined having a world where your automated system could analyze the visual, spatial, auditory stream around you in order to generate not only descriptions, which could help people who are blind navigate the world, for example, but also rich commentary on individuals' environments, such as stories, that could be used by people who were nonverbal, so people with nonverbal autism, people with cerebral palsy, in order to communicate directly with their loved ones using personalized language about what they thought, about how their day was, right? And the idea was that the person was always in control. The utterances were grounded on human-specified details about the world. This idea of natural language grounding was a fundamental part of natural language generation research. So the space of options that people could select from could reflect both what was true and also what they wanted to convey that was personalized to them. And the idea was that this kind of technology could level the playing field. So no matter what your ability status, no matter your neuroatypicality, you would be able to be who you wanted to be to meet other people where they were at, with you in control, opening up more equal access to relevant opportunities. So my thought and my hope, and this continues today, is that natural language generation and technology as a whole could make it possible for people to tailor the world to their individual needs in a way that had never been possible before. Great. So by 2015, I had moved beyond simple image description to more complex forms of description, visual storytelling. So this is generating a story from a sequence of images. This was a precursor to video. We didn't actually have the computational power at the time to apply deep learning to video streams, and so we did sort of the next best thing, which was sequences of images. And that summer, I led a project focused on generating stories from sequences of images. And I had planned to continue in this line of work, connecting vision to language in particular, and focusing on how to center people's needs from assistive, augmentative, and supplementary sort of perspectives. But something happened one day that stopped me in my tracks and forever changed the trajectory of my career. This was in 2015. And that was the moment I shared with my system a sequence of images of a catastrophic event that wounded 43 people. We were looking out the window from a third-story apartment, and a few meters away, a massive explosion had just shot fire thousands of feet into the sky. Smoke filled the air. It was a deep purple pink. This turned out to be a high-strength fuel air explosion caused by leaking petrol at an oil storage terminal. But my system examined the situation and expressed sheer delight. "This is a great view," it said. "The sky is beautiful. This is awesome." And its response to an event that had grave mortal consequence was one of expressing pleasure and support for what was happening. I had provided it with a set of photos taken just steps away from an explosion, and its response of awe completely overlooked the grim possibility of the loss of human life. And of course, this makes sense, right? So we were in a deep learning paradigm, so we were moving from curated data sets where we had carefully selected for different kinds of topics and different kinds of expressions of emotion, and instead we're now scraping images and their descriptions from the web. It's a great way of scaling up data. It's cheap, it's efficient. I made this argument to Microsoft, right? It is a very powerful way to get a lot of knowledge about the world and train really powerful models. But the kinds of things that people tend to take pictures of and share in bulk online tend to be positive and beautiful things, like sunsets and parties. People do share images of tragic events, but it's not at the level of volume of things that people tend to mostly share online, which tend to be quite positive. And actually, the language here tends to be fairly predictable. So if you see a sunset, you can basically always say it's a beautiful sunset. No one's ever like, this is a crappy sunset. So there's lots of fun things to say about the sort of natural language generation aspects of this. But essentially, the system had learned that everything was awesome. And we called this the everything is awesome problem. This was a recurring problem in the work that a lot of us were doing at Microsoft Research, where we found that by scraping the internet for information, trying to get as much as we possibly could in order to have our systems be fluent, it was accidentally learning that things were wonderful all the time and really had this like optimistic, positive view of things. And it was in that moment when I saw that it looked at this human destructive sequence of images and only could see positive things, that I suddenly saw how AI would pan out over the future. I saw the trajectory of AI moving forward as we focused with tunnel vision on getting higher and higher scores on benchmarks and incorporating more and more modalities. And I realized that we were missing the forest for the trees and were creating something that we wouldn't be able to control without detailed knowledge about how it would behave. And so it was in that moment in 2015 that I saw how the future would pan out from there, how to roll out from what we were doing at that moment. First would be generative AI systems were deemed good enough for global deployment. Second would be integration of functionalities that allow the system to act out events in the real world. And then a single instance of unsafe deployment interacting with a missile launch system. And to be clear, we're at step 2. So I was just struck by the fact that we were completely missing, that we had no understanding of the relationship between what we had been giving the system, what the system would do, and then how it would eventually end up behaving. So this brings me to one of the first realizations that I hope is sort of useful and constructive for the purposes of this get-together, and that's that catastrophic risk is deeply related to data set bias. A data set that is skewed towards positivity in the face of human destruction is reflecting a bias, a skew that centers on signals it's learned as positive or as things that you express positive words around, missing the larger picture. In fact, all data sets by construction represent a snapshot skew of everything possible in the world. So the world of AI has a tendency to assert false binaries. I think we've seen a few false binaries, at least maybe what I would argue is a false binary in this conference already. But one thing that's emerged is that either you care about bias or you care about global annihilation. But this misses the point that if you care about negative outcomes of technology, many of the solutions are the same. A likely foreseeable cause of catastrophic harm from a deep learning system would likely be due to skews in the data set that fundamentally affected its knowledge and its behaviors. Okay, so the current operating paradigm on data sets in AI is a bit chaotic from this standpoint. There's this implicit and sometimes explicit assumption that if you just get a lot of stuff from the internet and shove it into the system, you will be able to create a system that's general purpose, useful for all sort of kinds of things. And if it doesn't, you just have to instruct it to, once the model has already been trained. But what this misses is that general knowledge is actually a set of components of a lot of different things that we're just not specifying, right? So when we're scraping things from the internet, we have a ton of different topics, we have a ton of different domains, registers, the way people communicate, different sort of moods that are expressed, all these kinds of things. When we're building general systems, that's what we're getting, but we're just not specifying that kind of thing. And so this means that systems may act one way in one situation, a completely different way in another situation, and we really don't have insightful information about how it might behave because there's so much going on and we haven't appropriately quantified it. So the idea that more data is good and good sort of blinders on to what the data actually is, this sort of tunnel vision view of the priority being higher and higher scores, completely misses the relationship between input data and output behavior, right? So adding data that can lead to good and bad sort of situations, taking that data and just doing more of it doesn't mean that you will have good situations or global prosperity. It means that you will have more good and bad situations. And you will be more and more unable to predict what the behavior will be the more you don't pay attention to what the input-output relationship is. So that brings me to my first concrete research suggestion in this area, which is to create a science of how inputs affect outputs. Right? So this has a few pieces. One thing is coming up with methods to measure data. So just as we evaluate systems, so too should we measure data. And I have a paper on that on arXiv if you want to know more. It was one of my most brutally rejected papers I've ever had. Like reviewers would fight to have this rejected. But I think it's a really good idea. So I really want to put this forward as a fundamental subdiscipline within AI that really can use a lot of advancements. And I have some ideas in that paper about specific kinds of measurements you can pull from work in ecology, biology, all this kind of thing, about different sort of measurements of populations. These things can also be applied to data. There are tons of ways to quantify data. It is such a rich field. And once you come up with methods to measure data, now you can start looking at the relationship between those measurements and what happens with system behavior. So starting to make informed predictions about how input affects output, running ablation studies, running curated data collection sprints where you optimize for different kinds of measurements that you really want to have represented in your data set. Cool. So after my experience at Microsoft that fundamentally changed the trajectory of my career, I moved on to Google, starting a new chapter where I focused on trying to develop technology from the lens of what is good and what is bad. And once you're thinking about what is good, what is the right thing to be doing, then you're in the realm of ethics. I'm a computer scientist by training. I am called an ethicist more than I am called a computer scientist, which is maybe something women in the room can sort of understand. But once you're trying to think about what is good, what is the right thing to do, and how can I critically break down the system in order to figure out the best paths forward, you're in the realm of applying ethics. So I focused in particular, when I started at Google, on the value of fairness. That was my starter project, so easy project, just think about fairness in particular, just get that value down and then we can move on to the others. And it addressed the same issues of data set bias and disparate outcomes of technology that I had been concerned about at Microsoft. So where some subpopulations are more likely to come to harm than others, as well as how the different things that are represented in the data set are skewed such that it might impact the final system behavior. And what I came to learn is that no value occurs in a vacuum. They're interrelated and they bring tensions. So, for example, in pursuit of something like fairness, that might come up against a value such as justice. So if you're hitting everyone over the head equally, that might be fair, but it's arguably not just, right? Or something like safety. If you try and focus on monitoring systems in order to understand specific system behavior and so figure out whether it should be shut down or not, then you are coming up against privacy and surveillance issues. So it's a fundamental part of operationalizing ethics and realizing that safety, fairness, all these kinds of things are all parts of what we're talking about when we're talking about ethical AI. So that brings me to my next point. Ethical AI is not a thing as such. There's no such thing as technology that is ethical. There is technology that is informed by different ethical values. So when you're working on operationalizing ethics within a company, you're learning about different kinds of values, how to identify them in different processes, how to figure out what's being prioritized, and how to sort of tease out the tensions among them. So that means that the way the association is named is a little bit maybe of a misnomer. Maybe it should be the International Association for Safe AI, developed in the context of ethical deliberation, so that'd be IASEAI. Just rolls right off the tongue. Maybe it should be AI, the International Association for AI informed by human values with prioritization of the value of safety in particular. So that's would be IASEAI. I think, just think about it, just workshopping ideas, brainstorming here. So ethical AI helps with deliberating value tensions. Different projects and organizations will have different kinds of priorities. And one of the fundamental things that is important in order to try and make these things clear is transparency. This is my concrete suggestion number 2. Use transparency to enable ethical AI. And this is because transparency is a mechanism for ethical values. It's not necessarily something that's good in and of itself. It's an extrinsic value. It's a way that you can start realizing accountability, start realizing things like safety, because it creates a space for risk identification, risk assessment, being able to track potentially problematic outcomes with a lot more ease and with a lot more speed when things are starting to go wrong. It's a way to start realizing fairness, because if you have to report how well a system works across different subpopulations, then you're not going to release it until it's working relatively well. That brings me to my next concrete suggestion that people have largely missed in some of my original work on transparency artifacts called model cards. And that is to engage in disaggregated evaluation. That means defining the contexts, the subpopulations, and looking at how the system performs with respect to those different crosses of contexts and subpopulations. So there's a tendency to just look at overall performance, but in order to really understand how well a system works and makes informed predictions about when it should be used and when it shouldn't, it's important to actually disaggregate. So this can be things like missile launches, right? If you're worried about that sort of thing, and it can be things like hiring. Subpopulations are people most likely to be harmed, so it could be nations, right? It could be Muslim women who are disproportionately subject to harm, blue-collar workers, and then examine how well the system works with respect to those disaggregated characteristics. Okay, so I've talked about a couple key parts here and some information about coming to fair outcomes and safety. I'm going to fill this out just a little bit more here in order to help explain how we can directly connect what happens in the tech industry to ethical concerns and regulation. So this is the basic machine learning flow for development in technology. Data are collected, model is trained, model output is analyzed, model incorporated into system. That provides a hook in order to start understanding values and in order to start understanding rights that correspond to different parts of the technology development process. So, for example, for data collection, values that matter are things like consent, fair pay. For model training, things like appropriateness of the objective function and efficiency of training. And I think Kate Crawford will be focusing on that value in particular, et cetera. And then further, you can start to break it down in terms of the different people at play. So this is a way to center people in the development of technology. Who are the various stakeholders and people who are being affected at each stage? So data creators, data subjects, data annotators, people whose work is being taken, right? Those are data creators. Those are parties that are subject to outputs from the system, who are subject to what happens when we're developing the technology. And then the next step here, in order to understand how this starts connecting even more concretely to regulation, is that you can imagine each of these steps as giving rise to a regulatory artifact. So data set cards, model cards, rigorous evaluation report, system cards, user feedback. And that's using the value of transparency, the extrinsic value of transparency, to recognize different ethical values. Okay. So I made a chart to help people think through all of this. I'm not going to have time to go through it, but I just wanted to share it to let you know that even if you're not someone who really understands foresight, or not someone who naturally kind of has a lot of foresight, so some people are better at this than others, after working with a bunch of companies, I was able to develop this kind of chart that you fill out in order to understand the use contexts, the people, and cross them to work through different sort of situations. And I was asked by Time magazine in particular to break this down in context of the Gemini system, so working through the kinds of things at play here, so how it went wrong. And essentially, you have to understand that there's just a lot of foreseeable uses, and you develop in light of those foreseeable uses. So something like historic depictions as well as diverse representations. This is fundamental to operationalizing ethical AI development. Okay, cool. So that brings me to suggestion number 4, engage in rigorous processes of foresight. And I would be remiss to talk about foresight and sort of talk about things that already happened and then say, like, yes, we had foresight about this. So now I'm going to put out one more final piece, which is related to AI agents, and that is the argument that fully autonomous AI agents should not be developed. There's, you all should cite the paper. So we have this paper up now. We do the same thing that I've done throughout here, where we decompose things into components. We establish several agentic levels of increasing autonomy, This is pulling from how people are describing it. And we essentially get to a point where we recognize that as humans fully cede their control, as a system becomes fully autonomous, concerns such as safety in particular rise to a position where the foreseeable risks vastly outweigh the foreseeable benefits. So that's my foresight for the future now that hopefully is helpful. Great. And we work through it in light of different ethical values and lenses, so you can help with ethical deliberation there. So the suggestion for today is do not develop fully autonomous agents. Okay, so I provided a bunch of lessons that are hopefully useful, also some specific concrete research directions that I think can be helpful within this community. There's more work throughout that I've cited, and I can actually go to my last slide now because I'm quickly running out of time. But basically, so as companies and regulators look towards the future of how to create safe systems, they're overlooking one simple truth, and that's that whether the concern is existential risk in the future or active discrimination now, the solutions are largely the same. Tight control over inputs and outputs, measuring the effects of different data points on what a system can and can't do, breaking down social and technical systems into their components and examining each through the lens of different values, and then defining solutions based on foresight and due diligence. Okay, great, thank you. So I have a lot of stuff to say, so here's a list of everything I cited, and the stuff in bold is most relevant to what I just said, in case you want to find out more. And with that, yeah, thank you. We might have time for questions. Yeah.
2 questions. Time for 2 questions. Go find 2
Hi. Oops, I should stand up so you can tell where I am, because sound isn't.
Oh, yeah.
Yeah, if you just don't use the microphone, then you can find me.
Right.
So there was applause and discussion about no fully autonomous systems. What's your definition of fully autonomous?
Yeah, so I guess I can't switch back, but it's in the paper. But it's a system that can write and execute its own code outside of a human-defined sandbox.
Okay, so if I have a system that's, say, turning natural language into SQL queries, it's writing code, and I'm running it against a real database, is that autonomous?
I'm a little bit worried this is might be a little bit of a tangent.
Yeah, I think it's too broad a brush, and I guess we can dig into it offline about what the desideratum is.
Sure.
But I think there are tons of applications for fully autonomous AI that could be very valuable and
there are
prevent
benefits
mistakes
and risks,
yeah.
exactly.
So,
and we argue that the risks, the foreseeable risks, outweigh the foreseeable benefits.
okay, great.
I'm here, first row, right? I mean, just follow-up question from Tom's, right? This is, I mean, this last statement, right? We shouldn't do autonomous agents, right? I mean, while we talk, right? I mean, there's tens of thousands of students competing on an academic level, right? Mm-hmm. Thousands of companies competing for this, right? Mm-hmm. At the same time, we don't even talk about all the autonomous weapons which are right now, while we talk, being used and so on, right? Mm-hmm. So this is gone. Ghost is out of the bottle already. So you cannot push it back, right? So the question is how to deal with this ghost which is out of the bottle, right? So what technologies can actually prevent this? So and of course on the top there are at least 3 games, this geopolitical game as well, right? Where everybody's pushing, right? So so this is reality. You go to, I don't know, AAAI in a few weeks, right? To iClear, to all the conferences up to NeurIPS, right? Mm-hmm. Everybody will talk about and competing for this, right?
Yeah,
so this is reality, right? Yeah. This is reality, and we cannot escape out of it, right?
We can have a rigorous discussion about what an agent
but
is.
just discussion, nothing going.
Right, so discussion informs what we actually are doing. The way people are using the term agent right now has a lot of variability. Arguably, in some cases, it's just a marketing term. And I mean, yeah, definitely worth checking out the paper. You can see that the way it's used corresponds to an increasing spectrum of autonomy, increasing levels of autonomy. Where we are right now in terms of autonomy is a little bit more on the lower levels where humans always have some level of control. And I think that's where we need to be in terms of the benefits outweighing the risks. But as soon as we get to a place where humans are ceding all of their control, then we're in a place where technology will likely evolve in a way that's not beneficial for humans.
I'm sorry, but we're going to thank Margaret Mitchell and ask our questions